I was looking over some of the problems in the mid-segment problem set, and I came across number 26 and 27, and I thought that might give you a little bit of vexation. So I thought I would give you an idea about how to go about solving that. Because what you're given is the midpoints of the sides of a triangle, and you want to find the coordinates of the vertex of that triangle. So let's just think about how we could go about that. Let's consider a triangle, and I've got the vertices given to you. There they are, they're given to you, and I've also given you the midpoints. So, we've got everything we need, but what we're going to do is act as though we don't know these vertices. In other words, I don't know what this vertices is. 6, 5. Let's suppose I just know that there is a vertex there, and I'm going to call that x1, y1. And likewise, for 8, 1 down here, I'm going to call that x2, y2, and for the 2, 1, I'll call that x3, y3. And I'm doing that just so that we'll see this process and how it works and how it helps you to identify the vertices if you're given the midpoints. Now, there's a lot of algebra going to be happening here, so hang on, put on your algebra boots. First of all, we want to find the midpoint formula for each pair of these vertices. So, for example, I'm going to take x1 plus x2 divided by 2, and I know that has to equal 7. See? What I'm doing is I'm finding the midpoint between these numbers, these 2 points right here. So I'm doing x1 plus x2 divided by 2, and that should give me 7. Likewise, y1 plus y2 divided by 2, that has to give me 3. Because those are the coordinates of the midpoint, and this is how we find the midpoint formula. We average the x's, we average the y's. Now what this gives me immediately with a little algebra here is if I multiply both sides by 2, I get x1 plus x2 equals 14. And likewise, y1 plus y2 equals 6. Okay, now we want to do this for every pair of points. So I did it for x1, y1, x2, y2. Now let me do it for x1, x3. So I'm going to find that midpoint, and I see that's 4. See, this number right here, because I'm doing this point and this point. Yeah. So that has to equal 4. And then I want to do y1 plus y3, and that has to equal 3 if I divide by 2. Yeah, there it goes. So here's what we've got. We've got x1 plus x3 equals 8. And over here, y1 plus y3 equals 6. So no worries there. Now, the last two are x2 and y and x3. So here we go. We go x2 plus x3 divided by 2, getting the mid x, the middle x value should be 5. And then y2 plus y3 over 2, the middle y value is 1. So we get now x2 plus x3 equals 10, and y2 plus y3 equals 2. So we've got these things. Notice we've got this, and we've got this. Now you might be thinking, well, we've got a mess. How is this going to help us? Well, let's concentrate on the x's first. Let's just look at these x's. Here's what we've got. We've got x1 plus x2 equals 14. We've got x1 plus x3 equals 8. See, I'm just doing these. And then we've got x2 plus x3 equals 10. Now let me add these together and let's see what we get. Notice there are 2x1s, 2x2s, and 2x3. So here's what we get. We get 2x1 plus 2x2 plus 2x3 equals, if I add all of these up, I get 32. Now, every single time we do this, we're going to get 2x1 plus 2x2 plus 2x3. And then notice 14, I just add these 18 plus 14, and that's how I get the 32. Okay, now, let me divide out the 2's. So I get x1 plus x2 plus x3 equals 16. Okay, now you may not see where we're going with this, but we're going to in turn solve for x1, x2, and x3. So dig this. x1, just a little algebra here, is 16 minus x2 plus x3. See, I just brought the x2 plus x3 to the other side. Now, what is x2 plus x3? Well, it's 10. See, look at this. Let me, 10. x2 plus x3, that's 10. Okay, so let's see what we got here. We got x1 equals 16 minus 10, which is 6. Now, dig if you will. That's what we're saying x1 equals. And look, here is x1 right here. And that, yeah, it was 6. So you can see, yeah, this gave us what we thought we would get. Now remember, we're acting, the problem, number 26, which is what we're working on. We're working to solve this problem. We're not given what the vertex is. We have to find it. But knowing what it is ahead of time, you can see how this works. Okay, now let's find x2. Okay, so x2 is going to be 16 minus x1 plus x3. See? I'm just solving this thing. Okay, so x2 is equal to 16 minus, let's see here, x1 plus x3, that's 8. Okay, so that's 8. That's what x2 equals, and dig this. There's 8 right there. Hot dog, hot dog. Now, let's go ahead and do the next one. x3 is equal to 16 minus x2, or x1 plus x2, right? That's the next one. And x1 plus x2 is 14, so x3 is 16 minus 14, okay, which is 2. Yeah, 2. And there's 2 right there. Now, we would do exactly this same process for the y's. Okay? Now, I don't want to just totally spoil number 26 for you and work that problem, but that shows you how you would do it. Now, notice you're going to have x1 plus x2 divided by 2. You're gonna match up each one of these. Notice I had 3 midpoints. And notice I had x1 plus x2 equals, well, look up here. I had x1 plus x2 equals 7. Then I had x1 plus x3 equals 4. And then I matched up all of them. I matched up x1 and x2, x1 and x3, and x2 and x3. So don't get too bogged down in making a triangle that makes sense. Just the algebra alone, if you just work through all the possibilities, you'll get it. Okay. Just be consistent. Okay. Okay. So I think that will help you, and let me know if you have any further questions about that.